Welcome to Tech Talks Education. We are continuing with the calculation of empirical and molecular formula of compounds, and in this case we are going to look at something which is rather tricky, in that we are going to deal with a compound which is also having another compound in it. In this case, what I'm meaning is we are going to deal with the hydrated compounds. So the hydrated compounds consist of water crystallization. So let us try to see how we can deal with it. Now let's look at this example. Analysis of a hydrated compound Q gave 16.08% sodium, 4.20% carbon, 16.78% oxygen, and the rest being water of crystallization. Mark you the spelling of crystallization. So the first part of this question says calculate the simplest formula of compound Q, given that sodium is equal to 23, carbon equals to 12, oxygen equals to 16, and also we have been given the mass of 1 mole of water of crystallization. In this case, this is the relative molecular mass of water crystallization. It is 18. So we are supposed to calculate the simplest formula of this compound. In part B, we write particles of compound Q were left exposed in air for some time. One, state what was observed. 2, write equation for the reaction that took place. Next, name the process that occurred in B above. And then finally, name 2 other substances that behave in the same way as compound Q. So let us look at this question here. If you can see, it is rather bulky, and there is something small that I want us to look at here, which we could have not yet looked at. So we have been given a hydrated compound Q, and then we have been given the percentage composition by mass of the different elements in it, including water of crystallization. So firstly, they want us to calculate the simplest formula of the compound. Let us use this part here down. Let us not forget the questions that are following this one, part A. So let us calculate the empirical formula of this compound. Now, if we can see sodium, carbon, and oxygen, their percentage composition by mass in the compound have been given, but the water of crystallization, in fact, its percentage composition has not been given. So that's what we start with. In this case, percentage, we are now calculating part A, percentage of water of crystallization, or the percentage composition by mass of water crystallization is 100 minus these other masses here combined, that is 16.08 plus, we are removing the whole of this one from it, plus 4.20 plus 16.78. So what we are going to get from here will be the percentage of water of crystallization. So it will be 100 minus 16.08. From this answer here, we remove 4.2, and again we remove 16.78. So here I have 62.94%. That's the percentage of water crystallization in this compound here. So let us calculate the simplest formula. In this case, we are starting with the elements, and also we have a compound, and that is water of crystallization. So we have sodium, we have carbon, we have oxygen, and we have water. That's the water of crystallization. So we go to the relative, let's go to the percentage composition. Percentage composition of each. For sodium, it is 6.08%, carbon is 4.20%, oxygen is 16.78%, and then water of crystallization is 62.94. If you add these ones here together, you are sure of getting 100. So that will be the percentage composition of all these ones here combined together gives us exactly 100. So let's go to the relative atomic mass of each element, and then the relative formula mass of water given. So for sodium is 23, carbon is 12, oxygen is 16, and for the water crystallization is 18. Next is we are now going to calculate the number of moles. So in getting the number of moles, for sodium it is 16.08, we divide by 23. For carbon it is 4.20, we divide by 12. oxygen is 16.78, we divide it by 16, and then water is 62.94, and we divide by 18. Let us find out what we get from this working here. So 16.08 divided by 23, what we get is 0.6991304. I have not rounded off, so you also never you do that. Then we go to carbon, it is 4.20 divided by 12. And this one has given us exactly 0.35. Then for oxygen is 16.78. We are going to divide it by 16, and this one has given us 1.04875. Then for water of crystallization, it is 62.94. We divide by 18, which is 3.496666667. No rounding up. Let's go now to the mole ratio. So we are going to divide throughout all this number of moles here by the smallest number of moles. So let us try to see which one is the smallest here. Let us look at the first place value, ones. 0, 0, 1, 3. So this and this are smaller, as you can see from here. Then we go to tenth. This one is the 6. This one is 3. So I think this one is the smallest of all these. So we are going to divide all this number of moles here by 0.35. So this one is 0.699130434. We divide by 0.35. This one also 0.35. We divide by itself by 0.35. And this one is 1.04875. We divide by 0.35, and then 3.496666667. We also divide by 0.35. Let us see what we get from here. So we have got 0.699130.434 divided by 0.35. And here I have got 1.997515526. This one gives us exactly 1. So it's the ratio of this one to 1 to, then we go to 1.04875. We also divide by the smallest 0.35. And this one has given me 2.99642827571. That is for oxygen, and it is 2. The last one is 3.49666667. We divide by 0.35, and this one has given us 9.904769191. So at this point, since we have got the mole ratio already here, but they are decimal numbers, now try to round off to one decimal place and see what you get. If I round this one here to one decimal place, or to, approximately this one becomes 2, this one remains 1, this one remains 3, and this one becomes what? 10. It means that I will get Na2C1O3, and then it is having water crystallization. Then I say dot 10 water. So this is my empirical formula, or the simplest formula of this compound. So let us now go to the next part. We have got the simplest formula of this compound. The next part says that particles of this compound were left exposed in air for some time. We should state what was observed. We write the equation for the process that occurred. So let us start with the observation made. Now, sodium carbonate 10 water is a compound which, when left exposed in air, freely loses its water crystallization to the atmosphere. So we are now on part B. Roman 1 is here. Then Roman 2. It is always advisable for you to start with the equation for the reaction. Then you go back and you record your observation. So our equation is the sodium carbonate. This is our simplest formula, 10 water. That is sodium carbonate decahydrate. It is a solid. When you leave it exposed in air, we see that it starts losing its water crystallization freely to the atmosphere.